NENOMATICA, where mathematics meets YouTube excellence. Example: we will solve the compound inequality exactly as shown in the reference solution, and we will mirror each rule and step both algebraically and visually. Problem: solve the compound inequality. -2 is less than 2x minus 3, which is less than 1. Step 1. Compound linear inequality. If f of x is less than alpha of x, which is less than g of x, then we can treat it as two linked inequalities. Now, step 2. Solve a compound inequality by adding or subtracting the same number to every part. We will add 3 to each side of the inequality -2, less than 2x minus 3, less than 1. Highlight the added 3 in orange. Step 3. Divide every part by the same positive number to isolate x. We divide by 2. Show the fractions, then simplify. Step 4. Write the solution set as an open interval. Then show the final answer in green. The interval is 1/2 to 2. Quick challenge. Can you use the exact same steps to solve 3 less than 4x plus 1 less than 11? Take a moment to think, then check your work. A fast check. Subtract 1 everywhere, then divide by 4. You should get 1/2 is less than x, which is less than 5/2. In this lesson, we will solve two compound inequalities step by step, exactly following the algorithm shown on screen. First, you will see the word example, then the problem in bold orange math, and then we will proceed through the rules and steps. We start with the first inequality, 0 less than or equal to x plus 2 less than 3. We will apply the rule, add or subtract the same number on all parts of a compound inequality. To isolate x, we subtract 2 across the entire inequality. Quick challenge. Can you predict the first move for the next inequality? Take a moment to think before we continue. Now we move to the second inequality, -2 less than or equal to x over 2 minus 1 less than or equal to 2. First, we will add 1 to every part. Then, we will multiply every part by 2, a positive number, to solve for x. Step 1. Addition property of inequalities. Add 3 to every part of the inequality. Step 2. Split the compound inequality into two separate ones. Step 3. Solve each inequality. First, move terms and divide carefully. For the first inequality, subtract 2x, then subtract 3. For the second inequality, subtract 4x and divide by -2, reversing the inequality sign. Step 4. Take the intersection of the two solution sets. The intersection is empty. Now we solve the second inequality exactly as in the image. Step 5. Distribute 2 across parentheses. Step 6. Add 10 to every part of the inequality. Step 7. Divide all parts by 2. Quick challenge. Could you predict each step before it appeared? Problem. -3 is less than 3 over 2 times open parenthesis 2 minus x close parenthesis, less than or equal to 5. Step 1. Multiply every part by 2 to clear the denominator. Then write the new inequality. Step 2. Distribute 3 across the parentheses. Step 3. Subtract 6 from every part of the inequality. Step 4. Step 4. Divide all parts by -3. Remember to reverse both inequality signs. Step 5. Write the inequality in standard increasing order. Then state the interval notation. Example 2. Problem. -14 is less than -7 times open parenthesis 3x plus 2 close parenthesis, which is less than 1. Step 1. Distribute -7. Step 2. Add 14 to every part. Step 3. Divide by -21 and reverse both inequality signs. Step 4. Simplify the fraction. Step 5. Write the inequality in standard increasing order and give the interval notation. Summary. We followed the same 5-step algorithm for both compound inequalities. Clear fractions distribute, add, or subtract to isolate the term with x. Example. We will solve 2 compound inequalities step by step, strictly following the structure shown on screen. Problem. Solve the inequalities. First, 8 less than or equal to 3 minus 5z, strictly less than 12. Second, 2 is less than 1/6 minus 1/2 x, less than or equal to 4. Step 1. We solve the chain inequality for z. We can add or subtract the same number from all 3 parts. Here we subtract 3. Now we divide by -5. Remember, dividing by a negative flips each inequality sign. Arrange the result. Step 2. Express the solution set for z in interval notation. Step 3. Now solve the second chain inequality for x. Start from the original chain. Subtract 1/6 from all 3 parts. Next divide by -1/2. Again, flipping the inequalities is essential. Simplify and rewrite the chain in increasing order. Step 4. Write the solution set for x in interval notation. Quick challenge. Pick a test value inside each interval and one outside each interval to verify the truth of the inequalities. Final answers. Z is in the open interval from -9/5 to -1 inclusive. X is in the closed to open interval from -23/3 to -11/3. Example. We will solve the compound inequality exactly following the steps shown in the reference image. The problem is -1 less than or equal to open parenthesis -2x plus 1 close parenthesis over 3 is less than 4. Quick challenge. Can you predict the first algebraic move we will make? Step 1. Multiply every part by 3. Because 3 is positive, the inequality directions stay the same. Rule. Multiplying a compound inequality by a positive number keeps the signs. We write 3 times -1 less than or equal to 3 times the middle, less than 3 times 4. Now simplify to get -3 less than or equal to -2x plus 1 less than 12. Step 2. Subtract 1 from all 3 parts. Rule. Adding or subtracting the same number from each part of a compound inequality preserves the directions. Write -3 minus 1 less than or equal to -2x plus 1 minus 1 less than 12 minus 1. This simplifies to -4 less than or equal to -2x less than 11. Step 3. Divide all parts by 2, which is positive, so the inequality directions do not change. Rule. Dividing by a positive constant keeps the signs. Write -4 over 2 less than or equal to -2x over 2 less than 11 over 2. This becomes -2 less than or equal to -x less than 11 over 2. Step 4. Multiply every part by -1. Because we are multiplying by a negative, the inequality signs reverse. Rule. Multiply or divide a compound inequality by a negative flips each sign. So -1 times -2 is greater than or equal to -1 times -x, which is greater than -1 times 11 over 2. That simplifies to 2 greater than or equal to x, and x greater than -11 over 2. Finally, we rewrite in increasing order. -11 over 2 less than x less than or equal to 2. Quick reflection. Why did the symbols reverse in step 4? Because multiplying by a negative reverses order on the real number line. Summary. We maintain the exact step order. Multiply by 3, subtract 1, divide by 2, and multiply by -1 while reversing the signs. Our final solution interval is -11 over 2 to 2, open on the left and closed on the right. Practice. Try changing the constants and repeat the same 4 rules. Example. We will solve the compound inequality and visualize the solution set on a number line. Step 1. Multiply all 3 parts by 2 to clear the denominator. Then write the transformed inequality. Finally, simplify each part. And Step 2. Split the compound inequality into 2 inequalities connected by and. Step 3. Solve each inequality by isolating x. First inequality. Second inequality. Step 4. Combine the 2 results to write the solution interval, then visualize it on a number line. Quick recap. We cleared the denominator, split the compound inequality, solved both linear parts, and combined them to the interval open -3 to 1/2. Practice by changing the numbers and repeating the process. Final answer x lies between -3 and 1/2, not including the endpoints. Solve both linear parts and combine them to the interval open -3 to 1/2. Practice by changing the numbers and repeating the process. Final answer x lies between -3 and 1/2, not including the endpoints. We will solve the compound inequality 1 is less than the fraction 3x minus 1 over 2x plus 1, which is less than 2, strictly following a case split algorithm. First, we display the example and the problem in bold orange. Before step 1, recall the rule for multiplying a compound inequality. If the multiplier is positive, the directions stay the same. If negative, all signs reverse. Step 1. Consider the case 2x plus 1 is greater than 0. Because 2x plus 1 is positive, we can multiply all three parts by it without changing inequality directions. Then we simplify and split the chain inequality into two inequalities. Step 2. Consider the case 2x plus 1 is less than 0. Now, the multiplier is negative, so all inequality signs reverse when we multiply. We then simplify, split, and intersect with the domain restriction x less than -1/2. Finally, combine both cases by taking the union of their solutions. sets. The final answer is the open intervals -∞ to -3, union 2 to +∞. We will extract bounds a and b from a compound inequality by following the exact algorithm shown. Start with a given interval, multiply by a positive number, add a constant, and then read off the new bounds. Step 1. Start with the given inequality, -1 less than x less than 4. Step 2. Multiply all three parts by +2. Because the multiplier is positive, the inequality directions stay the same. Step 3. Add 3 to every part of the inequality. Again, adding the same number preserves the inequality directions. Step 4. Read off the new bounds. We have a less than 2x plus 3 less than b, so a equals 1 and b equals 11. Thank you for watching. Don't forget to like, subscribe, and hit the bell icon for more math lessons. NENOMATICA, where mathematics meets YouTube excellence.